In the last video, I talked about how things can dissolve or dissociate in water to make an aqueous solution. And in this video, we're going to talk about ways to describe these solutions, because we said things can dissolve, but then we need to determine how much of them dissolve, and we need to have a way to describe that. And the way that we describe that is the idea of concentration. There's a simple and fairly obvious abbreviation for concentration, CONC, and then there's the more slick chemistry version, which is just open brackets. All right. So if you see concentration, CONC, that's an abbreviation, or open brackets, and we'll see how that works in a minute. So what is the concentration? Well, we said a minute ago that we needed a way to describe how much stuff you had in there, how much stuff dissolved or dissociated, and we'll have specific vocabulary for that. Right now, though, the definition, our root definition of concentration, is just a measure of the relative amount of solute to solvent in a solution. And that brings up two vocabulary words that we need to address right off the bat, and those words are solute and solvent. And I'll look at a real-world example here in a moment, but let's get at least the skeleton of these vocabulary terms laid out. What is a solute? A solute is the species that dissolves or dissociates in the solvent. And I'm going to leave room here for a secondary definition, because it turns out that isn't enough in some cases. Our solvent is the species that does the dissolving, right? The species into which the solute dissolves. And we're going to have room there for a secondary definition as well. And I just want to do a visual for that, because it's not always obvious what the solute and the solvent are. And I'm going to start a little bit backwards. I've got some Kool-Aid here. I don't know how focused that's going to be. And I've got some water here. And I have something else here. And so if I have two clear and colorless polar things like water and we'll say grain alcohol, ethanol, and I mix them together, you can't really tell which is doing the dissolving and which is being dissolved in that type of situation. And so these definitions don't help us too much, all right, when you're trying to look at it visually. If you have something like sugar or salt that you're dissolving in your solution, it's fairly easy to say, all right, I've got this Kool-Aid mixture, and I'm going to put it in the water and stir it up, and the Kool-Aid is dissolved in the water. The Kool-Aid is our solute, and the water is the solvent, right? And that's just sugar water, really. And as we saw in the last video, there is sugar in sugar water. So in this case, it's very obvious. The solute is our Kool-Aid powder, and the solvent's the water. In our other case, it wasn't so obvious, and that's why we need these secondary definitions here. Hold on, I need to dispose of the evidence. Delicious. So our secondary definition of solute, and this is kind of hand-wavy, is just to say that it is the species present in lesser amount. So I'm going to write that it is generally in lesser amount. All right, and that's not true in all cases, and I'll show you an example of that in a second, but it's good enough for our purposes if we have to give an answer. And so, correspondingly, the solvent would be the species present in greater amount. Now, is there a way to make that not true? Yeah, if we just take our solvent, you know, maybe that much solvent, this is what my kids do when they make Kool-Aid, and then they're like, all right, I've got this 10 milliliters of water, and I'll dump in some Kool-Aid. All right, I certainly have more Kool-Aid there than water, But the water is still the solvent. It is still the thing doing the dissolving. It happens to be saturated. It's not even dissolving all the solute that we have there. But this pink thing isn't necessarily true, but if you can't tell which thing is doing the dissolving and which thing is being dissolved, it's usually a safe bet to say the one you have more of and the one you have less of. So I'm sure people will find issue with that, but that's fine. There are many different ways to describe concentrations, relative amounts of solute and solvent, and I've got a few listed out on this sheet, and we'll go through those more in detail later. And you've probably, outside of science, or if you have a science class where you studied this, molarity, molality, mole fraction, percent, maybe parts per million. So of those, I would guess maybe you've heard of molarity. I'm sure you've heard various percents. You might have heard parts per million in environmental science and stuff. I just was walking around my house grabbing a bunch of crap to see if we could get the concentrations on them. This rubbing alcohol, isopropanol, 70%. It doesn't tell us what kind of percent, and that's an issue for another time. But it says isopropyl alcohol, 70%. I have this toothpaste here, and this one's actually super interesting. All the toothpastes have some version of this, and at least the fluoridated toothpastes. But if you look, it says sodium fluoride, 0.25%, and they don't tell us what kind of percent, but they do say it's 0.15 weight volume percent fluoride ion, which is kind of neat. Potassium nitrate, they just tell you 5%. Other products that I have here, some hand sanitizer, which is a big deal in these COVID-19 times. 63% ethyl alcohol, grain alcohol. They say above 60% is pretty effective. Then it's got some inactive ingredients. We've got this Aquaphor for cracked skin, 41%. Whatever. Off, Deepwood's Off bug spray. This is the important one here, DEET, 25%. Works incredibly well, although carcinogenic, they say. Hydrogen peroxide, 3%. Says 3% right there. We've got some Clorox cleanup, cleaner plus bleach. Usually sodium hypochlorite is what we associate with that bleach smell. And there it is, sodium hypochlorite, 1.84%. Other, 98%, whatever those things are. And I grabbed this Fantastic out of the laundry room. Whatever it is, there's its breakdown by percents. And it's interesting to note that we don't see what types of percents they are on almost all of those products. And we'll talk about that in a different video. But for right now, I just wanted to give you the idea that you've seen concentration before. This idea of you have a relative amount, some ratio. The amount solute to the amount of solvent, or the amount solute to the amount of the solution. Alright, so that's the basics of what our solutions are going to be. You've seen some examples here, and it turns out most of the stuff you see around the house gives your information as a percent, and we'll see why that is. But that is for another video.